Welcome back. My name is Davor, and this is the second video in the electrostatic demonstration series. If you haven't seen the first video, please go there first. In the first video, we talked about how objects can be charged by rubbing them. They can be negatively or positively charged, and negative charges and positive charges can attract or repel each other. Like charges attract, opposite charges repel. In this experiment, we're going to look at how charged objects can attract neutral objects. So, what do you think will happen if I take this ordinary plastic rod and I bring it close to these pieces of paper on the table? No. Nothing seems to happen. What if I rub this rod? Now remember, in the last demonstration, we found out that rubbing a plastic rod with wool makes it negatively charged. So let's see what happens now. Wow. Can you see all the pieces of paper are sticking to and they're attracted to the rod? But wait a minute. We know that negative and positive charges attract each other. And this rod was negatively charged. But the pieces of paper were neutral. We didn't charge them. So why were they attracted to the rod? Well, all objects, as we know, have negative and positive charges. And neutral objects can be polarized. That means when a charged object comes close to them, the molecules inside the objects rearrange themselves so that one side of the object is positively charged and the other side is negatively charged. And so that's what happens with the pieces of paper. Because this rod was negatively charged, the pieces of paper, the molecules change so that the negative charges are further away from the rod and the positive charges are closer. And that's why they're attracted to the rod. The same thing happens, a similar thing, when I use this can. Now it's slightly different with the can because the can is a conductor. And in the conductor, electrons can actually move around. Remember, we talked about electrons. They're really small and they can move around. So in the conductor, a very similar thing happens. The electrons will move away from the negatively charged rod, which will leave this side of the can positively charged. So let's see what happens when I bring the rod closer to the can. Can you see the can is attracted to the rod? That's because the negative charges moved to this side of the can and the positive charges were on this side and they were attracted to the rod. We can actually see the same thing happens with a balloon. I'm first going to show you the balloon with these pieces of paper, and then later on we'll go to a wall and I can show you how we can stick this balloon to a wall. Now instead of using this wool, I'm actually going to use my hair. If you have nice dry hair, it should work. So let's see what happens. Wow! Look at how many pieces of paper is stuck to it. Alright? And that's because the balloon was charged by rubbing up against my hair. Now, I've been using a plastic rod this whole time during all the experiments. But what if I was going to use a glass rod? Now I'm going to use this piece of wool and this glass rod. And let's see what happens when I bring it close to the pieces of paper. Huh. Nothing happens. So why is that? Well, scientists have done many experiments with static electricity, and they've come up with a way to see which materials are good at giving up electrons, so that means becoming positively charged, like the wool, and materials which are good at taking electrons and becoming negatively charged, like this plastic rod. And they put all this information into a series that they call the triboelectric series. And looking on the series, you can see which materials are good at taking up electrons and which are good at giving up electrons. And if we look at glass and wool in the series, they're very close to each other. They're both very good at giving up electrons. So when I rub the wool against the glass, the wool wants to give up electrons to the glass, but the glass does the same. And so they both stay neutral. With the plastic, when I rub it against the wool is very good at giving electrons, and the plastic is very good at taking them. And so that's why the plastic becomes negatively charged. If I were to use something different like silk with glass, we might see a different effect. Now I want you to try and rub all these we've got different types of materials and different types of rods, and see which ones are great combined together to make positively and negatively charged materials.